apparently it's going to work now. We'll see.
Isn't that what it was doing before, though?
Yeah.
Now it's all of a sudden fixed.
Whatever.
Cool.
Who knows? Take a look at the opening paragraph. It says, in most applications of trigonometry, angles are measured in degrees. However, when you go beyond this course, pre-calculus, definitely calculus courses, you get away from describing angles in terms of degrees. There's another measure that we use out there for angle measure called radian measure. Radian measure allows us to treat trig functions as functions with domains of real numbers. Remember, with function notation, when you worked with functions in algebra, x squared was a function. You entered in a real number, out comes a real number. So that's going to allow us later on, not quite today or Monday, that's going to allow us to start thinking of our trig functions, sine, cosine, and tangent. Instead of the domain being angles and degrees, we can then start thinking of the domain as being real numbers, which is what we have here when we're dealing with an angle measure in radians, which you'll see here in a second. So let's first define what a radian is. If you were to take any circle of any radius, radius could be 1, radius could be 2, etc. And if you were to swing that terminal side of your angle in a position where the distance covered, what I mean by the distance on the circle, when this distance right here equals the radius of the circle, when that happens, the angle that you've just defined is an angle that has a measure of 1 radian. Okay, so how far is 1 radian? Well, it's however far it takes to make the distance covered equal to the radius of the circle. A little bit abstract if you haven't had this already, but that's what a radian is defined as being. Okay, so far?
So that the opening
Has a
in
measure.
between the measure is equal to the radius of the circle. R equals R.
This theta variable is equal to 1 radian when this distance covered on the circle is equal to the radius of the circle. So if you have a circle of radius 2 and you travel 2 centimeters, and if you were to swing that angle such that this arc has a length of 2 centimeters, you've traveled 1 radian of degree measure. Make sense? So knowing that, you know, the following 3 bullets would make sense. So therefore, an angle measure of 2 radians would intercept an arc double the length of whatever the radius is, because you're traveling 2 of those. Likewise, an angle measure of 1/2 radians would intercept an arc whose arc length is 1/2 of the radius, etc., etc., etc. So if theta is a central angle, now what is a central angle defined as being? Central angle simply means that the vertex of the angle is on the origin, 0, 0. So if you have a central angle with a circle, radius r, and it intercepts an arc of length s, then a quick way that we're going to define is getting that angle measure, guys. There's two flavors of this formula. You can think of this angle theta being arc length s divided by radius. So in the case you would have, if the arc length, right, if the arc length would equal the radius, r divided by r gives you 1, and that's how we have the definition of a radian set up. It's equal to 1 when the arc length equals the radius. Another popular format of this proportion, or this small formula or equation, you simply cross multiply both sides. So arc length s, which is this length from here to here, that's what we define as being arc length. Another way of getting arc length is you simply take r times the angle measure, and the angle measure must always be in terms of radians. Those we're going to use frequently in the next couple of pages. Do you have any questions so far? Baby steps with this. First baby step is, let's just simply take a look at how we convert angles in degrees to angles in radians, and vice versa.
But what was the last, you said S equals theta times
S equals R times theta.
R times theta. Okay.
We take this guy right here and we cross multiply it. So think of theta as being theta over 1 and cross multiply. Anything over there? Now, converting between degrees and radians. Give me some other equations that you remember dealing with circles. If you have a circle of radius r, what are some other formulas that you recall using in the past dealing with circles? Got to be 2 at least in particular, you know.
2r equals the diameter.
Okay, there's a start. And the other ones?
Circumference equals r squared something.
Nope, that's, you're thinking area, pi r squared. What's circumference? That's the one I want.
Circumference
2r. Isn't that pi times the diameter?
That's one way of looking at it. Circumference is also 2 times pi times r, right? 2r gives you diameter. Pi times diameter would also give you the circumference. Okay. So 360 degrees would be the whole way around the circle, right? So I want you to be thinking, hey, what about arc length? Arc length. What's the arc length if I go the whole way around the circle? Would be the circumference. Would be 360 degrees would correspond with the circumference being.
Repeat that.
Think of your angle measure being 360 degrees. You're going to go the whole way around the circle. All right, circumference is the same thing as the arc length, right?
360 degrees.
So what's the circumference going to be if you go the whole way around the circle? Maybe I'm not asking that the right way.
That's what I think. 360 degrees, and if you're saying the whole way around the circle.
360 degrees corresponds with the whole way around. So what would be the arc length the whole way around?
180. I don't know. 0.
No. I'm looking for something to substitute in for the circumference. Circumference is 2 pi r. I'm looking for something you could substitute in for the circumference.
So radians.
Here's a hint. If you think of, compared to what you just learned here, right? You also know that circumference or arc length is the same thing as r times theta, right? Then the whole way around is r times theta. So you have r times theta equal to 2 pi r, right? Because these two, in a sense, are the same thing. Circumference around the circle is the same thing as the arc length around the circle. So when dealing with whole way around the circle, how would you solve this little equation here? You can divide both sides by r, right? And you get that our angle measure that would be involved would be 2 times pi. So that was a long way of trying to simply get you to see the relationship that 360 degrees is the same thing as 2 pi radians. Those are one and the same. 360 degrees is the same thing as 2 pi radians. And then you could even make it a little bit more simpler. Let's take the 360 degrees equals 2 pi radians, and
Is
let's
that
do.
the symbol for? I'm sorry. Is that the symbol for radians or something?
No, there isn't. Well, it's just 2 pi.
2 pi then. That's what.
2 pi. Then you could also put r. I think they use rad at the end of that to define radians. But it's 2 times pi. That's the number of radians that are involved.
Okay.
We're going to divide both sides by 2 and think of this relationship. There's how we're going to convert it from one to the other. 180 degrees is the same thing as pi radians. And we just divide both sides by 2. And that's what they have here for number 1 and number 2. How can we convert between degrees and radians? It's just a matter of we're either going to multiply by pi over 180 or we're going to multiply by 180 over pi to go from one to the other. And if you get confused as to which one should you use, you want to use the one that the units that you don't want any longer cancel each other out. So what do I mean by that? Letter A says convert 45 degrees into radians. So which one of those am I going to multiply by? I'm going to set it up as 45 degrees. I'm going to multiply this by pi over 180 degrees. Because do you see how I would end up with the degrees on top and bottom, and degrees are going to cancel each other out? To get to know your fraction button on your calculator, it's going to help you. When I look at this, I'm going to say, well, I'm going to take 45 times pi and then divide that by 180. So really the only part I want to simplify, or ask the calculator to simplify for me, 45 over 180 is the same thing as 0.25. Now that one is obvious. You know that that's 1/4. But some of these decimals that may not be so obvious later on, remember you can hit the math button, enter, and it'll change it to a fraction for you. So 45 pi over 180 is the same thing as 1 pi over 4, or pi over 4. So 45 degrees is the same thing as pi over 4 radians. You're simply converting it from one to the other. 45 degrees would be the same thing as pi over 4 radians. Now the other one's not quite as simple because it's got a decimal. It's 249.8 degrees. So this one may not come out to be a nice fraction, if at all. So again, we'll take 249.8 degrees and multiply that by pi over 180 degrees. Now this one would have 2 correct answers, and it all depends on how the directions tell you to state your final answer. But the first answer I'm going to give you would be considered more of an exact answer. Let's just simply take 249.8 and divide that by 180. 249.8, divide that by 180, and that's 1.3. Let's just make it 1.39. So one possible answer would be 1.39 pi radians. You can leave answers like that. You'll see answers like that. 1.39 pi radians.
When you say 1.39 pi radians, we don't have any sort of notation to say radians.
RAD. Sometimes they just put RAD on the end of it.
Okay. I mean, are we going to have to put that in the answer? Or,
We know what we're...
Okay.
Yeah, we'll know. Obviously, however, when you want to specify degrees from this point on, you should draw the circle so you don't get it confused with 45 radians, right? Another correct answer for this one would be that you actually take 1.39, or whatever the previous answer was, right there's the whole answer, 1.38, and I hit the multiply by pi button. Use the pi key, second button, and then the caret throws the pi symbol there, and here would be an approximate answer, 4.359. You can make that 4.36. Both of those are the same. You could state the answer as 1.39 pi radians, or you could actually state the answer as 4.36 radians. It's the same thing. You'll see it written both ways.
No, we shouldn't round on that.
Which one?
That last one, like the 4.366.
I did. The 9 kicked this 5 up to a 6. You may not have taken... what do you have?
1.39.
1 point. You have 1 point. So you rounded this from the start. I used that.
Yeah,
whole,
that's why I took what we. Yeah.
Okay, that's why we're off a little bit. I took this whole answer, not only what you're seeing, but probably the other 10 digits it's in memory, and just simply multiplied that by pi. You should leave everything in your calculator as much as you can And you don't want to be hitting intermediate equals throughout one problem because you're going to be losing accuracy through all that.
An easy way to do that if you have a lot of factor numbers right above 1 stored, and then you get alpha and assign it to a variable. And whenever you enter that, it'll recall a number.
Spoken like a computer programmer. You can do that if you want.
Yeah, I don't.
We understand. Let's go in the reverse order now. Here comes angle measures in radians. Radians, and I want you to also notice, see, they're not even labeling it themselves. That they don't have the word RAD. Now that's only because they're telling you in the directions that they're in radians. But now we want the pies. Think of it this way: when changing from radians to degrees, you want the pies to cancel out. So we're going to take 9 pi over 4. Multiply that by 180 degrees over pi. The pi's would cancel out. 4 goes into 80 evenly, and take the remainder of that times 9, and we get, 405 degrees. 9 times 180 divided by 4 should give you 405 degrees. So a 405 degree angle would be equivalent to an angle that's 9 pi over 4 radians. Letter B. Well, we're going to take 4.25 radians and multiply that by 180 degrees over pi. Now this time, our angle measure in radians wasn't in terms of pi. So there will be no pi's canceling out here. You'll have to simply say, calculator, take 4.25, multiply that by 180, and then turn around and divide by pi. And then we can round this off to however many degrees, tenths, hundredths, whatever we're told to round off to, 243.51. 0.5 degrees. Or you may actually see problems where you'd have to write it as 243 degrees 30 minutes, right? 0.5 would be 30 minutes. So you may also be asked to state it as minutes and seconds, which I'm not going to do that to you on the exams, but just don't forget how to convert things to minutes and seconds. Are we okay with converting from one to the other? You're either going to multiply by pi over 180 or multiply by 180 over pi. What's more important is to understand the concept of what a radian is at the moment, what a single radian is.
It's how much your circles are.
Well, just another quick example. You know, if you had a circle of radius 4, and I said, okay, give me an angle so that the distance from here to here is also 4, then you've just created an angle that's 1 radian. Pretty much what it is.
So it just equals the radius no matter what.
Where you have to, because circles are going to change in size. It's whatever you have to move it to make the radius equal the arc length. That's defined as being 1 radian for that circle. Okay?
Okay, and then you can have up to how many over radians?
Yes.
Okay.
Yes. Right there we had an angle that was 4.25. Okay? So if we define this to be 1 radian, if you go about another 3 of those, that would be that angle that they're talking about. All right? All right. Moving on. This would be a great picture to keep handy with you when you take exams and quizzes and whatever from now on. This will allow you to convert from radians to degrees really fast. And these are the special angles. These are your quadrantal angles, 0, 90, 180, 270. And then these are also all of the other special angles that have trig functions that come out to be exact values. Sine of 1/2, cosine of 1/2, all those that we talked about in a section or two ago. Okay? Guys, what I usually do with this is I definitely remember my 0, 90, 180, and 270. Those are simple. 0, 90 would be pi over 2, because remember, 180 degrees is pi, right? So from here to here is pi. So half of that would be pi over 2. You add on another pi over 2, you're at 3/2 pi, and then you're back around again to 0. So when you're asked from this point on, what's the sine of pi over 2, you got to kind of quickly be able to say, okay, pi over 2 is the same as 90, and the sine of 90 is 1. So therefore the sine of pi over 2 is 1. Okay? Those 4 angles are kind of easy. Let me give you my advice for all of the other ones. Here are the only 3 I remember. And what helps me is 45 degrees is pi over 4. That's the same number as that. 45 degrees, pi over 4. The other 2, I got to start thinking reverse, right? 60 degrees has a 6 in it, so I don't want that one, so it's pi over 3. 30 degrees has a 3 in it, and I don't want that, so it's pi over 6. And those are the only 3 I remember. 30 degrees, pi over 6. 45 degrees, pi over 4. And 60 degrees is pi over 3. Because now, if I want to start talking to you about a 120 degree angle, how many radians is that? I remember 60. 60 is pi over 3. I have to double 60, right, to get to 120. So if I double pi over 3, that's 2 pi over 3. So if you go out to the 120, notice it's 2 pi over 3. And I look at 210 as 7 times 30 degrees. See what I'm saying? So I only ever remember the 3 that I have the red circle around, and it helps me get all of the other ones pretty quick. Any discussion there? Any discussion? Just kindly nod your head if you don't want to talk to me. Yeah. What?
I'll take a picture. It's too late.
Dude, you just spent $1,000 on a code to get you to a website. This is in there.
Oh, yeah.
Okay, let's find each function value. This is no different than, hey, find me the sine, cosine, tangent of various angles. So start thinking, using this picture up here. I would hide the picture, see if you can get some of these on your own. But like we just said a minute ago, 2 pi over 3 is like saying this is 2 times a 60 degree angle. Pi over 3 is 60, so we're doubling that. So tangent of 2 pi over 3 is the same thing as the tangent of a 120 degree angle. And the 120 degree angle had a 60 degree reference angle. And what's the tangent of 60? What's the tangent of 60?
2 over, square root of 2 over 3.
Nope. It's the tangent of a 60 degree reference angle. Root 3. Now the question is this final answer positive or negative? What quadrant are we in? We're in quadrant 2. Tangent's negative. So final answer, negative root 3. I don't expect you to be able to do that very fast. It's going to, after you do, we're going to probably spend 90% of the rest of the course dealing with radian measure. So you're going to get really good at looking at tangent of 2 pi over 3 and possibly be able to go right to that. Me, however, I'm going to be honest with you, I have to always convert to degrees, and then from that point, I do my trig functions, for whatever reason. Don't know. Disability that I have, I guess. How about the middle one? What's 3 pi over 2 the same as? Well, pi over 2 is 90. So 3 pi over 2 would be the 270 degree angle. So this is the same thing as the sine of 270 degrees. And what's that one? Negative 1. 0, 1, 0, negative 1, right? I go around the counterclockwise. And let's take a look at the last one. Cosine of negative 4 pi over 3. Walk you through this. What's pi over 3? No, what's pi over 3? Those are the three that I remember. 60 degrees. This one's 4 times that, right? So I look at this and say, hey, this is the cosine of negative 240 degrees. And where are we if we go 240 degrees in the opposite direction? What's 360 minus 240? What's 360 minus 240?
120.
So this is the same thing as the cosine of positive 120. Going 240 degrees clockwise is the same thing as going 120 degrees counterclockwise. You're at the same location. So 120 degrees, we are in quadrant 2, cosine is negative. What's the cosine of a 60-degree reference angle? Cosine of a 60-degree reference angle. Cosine of a 60-degree, the sine of 30 is 1/2, so therefore the cosine of 60 would be 1/2.
1/2.
So the final answer would be negative 1/2. It's good to know that you guys are working on your homework.
Hey, I did last night.
Good, good. Because this stuff, you know,
Section 1-1, that stuff is easy. You give me a test on that, I'll be...
any questions so far? Again, we all know it's just like learning Spanish 1 vocabulary. You don't get good at this stuff until you start just practice. I'm a little rusty myself, only because I don't teach this every semester.
What's up with that?
What do you mean?
Is there just not enough interest in
Not enough to get a full class every semester, so they spread it out.
Well, most students are going to take, what, 051 in the first college algebra, if that,
Yeah.
most of the time.
Now, as we grow, eventually we'll start offering this every semester, hopefully. Now that we've mastered converting from one to the other, we kind of know what it means to be a radian. There are two applications of using radian measure. One is finding or determining the arc length on a circle, and the